Hello everyone and welcome our Simplified Midterm project of AI and cybersecurity. And it is based on cloud-based PE malware detection API, and it is continuation of Lab 5.4. So we have already trained our model in Lab 5.4. In this project, what we are going to do is we are going to take that model, we are going to deploy that model in AWS SageMaker as an endpoint, and then we are going to make a streamlit client so that we can query the endpoint via JSON application responses. So uh, up, we in the client we put a PE file, the features got extracted, and the features are sent to the endpoint. The endpoint classifies the uh, PE file as malign or benign, and the result is sent to us in JSON format, and the client shows us that whether the PE file is benign or malign. So going through it, so let's talk about PE files. So PE files or portable executable files are uh, Windows OS executable files. So for example, we have VLC, Explorer, or let's say Chrome.exe. All those exe files are PE files, and they contain many characteristics as architecture, entry point, and section layout, and can help us to know whether a file, an executable, is a malware or not. And so we utilize those data and we feed into a neural network to learn the features, to get to know what type of features represent malware and whatever feature doesn't represent malware. And yeah, so in this image, you can see a 32-bit PE file structure. There are many features and data in this PE header, and we can extract those to get information about the type of file. And in this l- project, we have used scikit-learn library. And scikit-learn is a powerful and versatile machine learning library. It is mainly used for traditional machine learning algorithms. It is one of the most popular library in the data science machine learning world. And we use this library for many tasks, such as it's used for very basic tasks such as preprocessing, cleaning of data, as well as using uh, traditional and very complex machine learning algorithms to train our model. And yeah, it's very intuitive and very easy to learn this library. And yeah, we use this library. And speaking about our algorithm, we use random forest algorithm inside the scikit library implemented by this library to train our model. It's a very powerful model algorithm, and we are basically doing classification, and we are trying to classify if a given PE file is malware or it's a benign file. And for this, we can see that we have a sample and it has many features. And this architecture works on the process of, you can say, as if and else, if and else, if and else. So if this, then this, then. So there are many paths that a PE file could go through, and there are many models. So this is one, let's say a model one, a model two, a model three. So there are different branches out of it, and random forest works on the majority voting or averaging out of these results. So yeah, it's a very robust model for predicting whether classifying mm, things. So yeah, and after we have done this in Google Colab, or we can also do this locally in our Jupyter notebook. But since we are working with malware and all, it is better to use cloud-based uh, remote mm, uh, mm, cloud-based remote uh, machine, or you can use a local VMware or VirtualBox. And for deployment, we have used AWS SageMaker. It's a very fully managed machine learning service provided by AWS. It is used for many tasks such as building, training, and deploying. And the most important thing about AWS SageMaker is that we have a variety of instances, a large instance, a small instance having higher GPU, higher RAM, many cores. So we can use that as according to our use cases. And we are making use of it because we are deploying it as an endpoint, and there can be many users that are querying our endpoint. So yeah, this is one of the main use cases for AWS SageMaker. It's scalable and it's a secure cloud infrastructure, so we don't have to worry about that. So as already stated, this project has three parts: building and training the model, deploying the model, and creating a client application. So we did the building, we did the deployment, and for creating a client application, we use Streamlit. Streamlit is a Python library that can be used to create a web application. And yeah, and so let's see project methodology. Building is continuation for lab 5.4. We just download the model, download the featureizers or any other uh, scalars that we have during the training. So yeah, we can use the same thing for the testing purpose as well, and deploying the deploying the model as an endpoint API. And we made sure that we don't cross the $100 AWS credit limit. Client, streamlit, project results. So yeah, the model was trained, it was deployed, it was verified using streamlit. We'll go through the demo later on and we'll see evaluation. The evaluation was pretty good. We can see 99.5% accuracy. So there could be many reasons why it was very high accuracy. Uh, maybe the it really shows that our model learned very well, but there could be other issues as well, like there could be data leakage, there could be overfitting, and so many other things. But yeah, this is the model that we have and we have deployed. And the result and conclusion, our trained model achieved accuracy of 1 on testing, held our dataset with 1 precision and 1 recall. It is doing superb in test as well. So you can see this is for a test, and this is a screenshot of our end client, SageMaker. We'll go through that once more. So this is for just two files, PE files. This is for many PE files. So our conclusion. So the project was concluded successfully. We did all the three parts of it. And yeah, the code and all the documentation uh, is already in the GitHub repo. And there will be a link to a YouTube presentation. And what were the hurdles or the future work? In this, the only hurdle that we can think of is two parts. So one would be the uh, Ember library or dataset, I would say, because mm, mm, not the Ember, because we are not using Ember right now, but yeah, the scikit-learn. So there is a AWS SageMaker learning curve that is a bit hard to grasp. And yeah, that would, and also the pre-processing of the PE files before it is sent to the cloud is also a bit tedious. So yeah, but not that much. But still, the main hurdle would be the learning curve of AWS SageMaker. And what the future work could do is transfer learning. We could use transfer learning that has not been done. And since we have very limited data set and we have trained on a limited data set, we have achieved very high accuracy, and could not be the it might not be the best model to test out in real world. So we could use more larger and more diverse data set. And these are the resources that I have used to complete this project. And let's go through another part. So um, let's see our collab. So this is our code we used to train the model. So we got our data, we unzipped it, we went to the directory, we installed PE file library, and we went through the samples, which is benign or malware. We made our training and test dataset, data samples. We made different functions or methods to read the file, to get n-grams, to extract n-grams, and to process imports, and get section name. And we are mainly dealing with 2 grams, binary grams. And we got the K1 most common n-grams list. And we are going to train this by seeing all those section names and the most common imports and all. And this we are doing featureizers, import featureizers, section name featureizers. So there are many featureizers. We are also saved these featureizers to be later used for testing purposes in our deployment. And so you can see the classifier, random first classifier is fitted on training and training data. And we have a score of 99.5. And this is for the test, I suppose. Yeah, this is for the test. We're doing the same process and we are importing those two featureizer. We are fitting the featureizer for test, not featureizing, we are transforming for the test and we are predicting some values. And you can see the training score 99.5. Let's see for testing. So testing score is here. One is the precision, one is the recall, and one is the F1 score. So yeah, you can see this is our code for our training. We have downloaded our model and our visualizers. So let's see for code in the, okay. So this is our deployment code. So for SageMaker, let's see in SageMaker itself. I think it would be better to see in SageMaker. So let's go to SageMaker. And here, what we can see is simplified midterm code, right? Mm. Yeah, here. So we have installed our libraries, what we require. We imported our libraries, and we acquired our credentials and our role. We got our session, and this is our model artifact. So we have model.joblib and our inference.py file, and we have uploaded that to our S3 bucket. And we deployed the framework as sklearn version 1.2.1 py3, and the instance type is ml m5 xlarge. And these are the code for model creation, EPC creation, EP creation, and finally you can see it is creating, and it has been created. We can say that endpoint here sklearn local EP, and it is in service. And also what we can see is our inference. Let's go to our inference as well. So this is our inference.py. As you can see, it's a simple inference.py. There is nothing much. So we have joblib to load our model, OS and JSON. So we get our input. This is our model. This is our predict function. And finally, we just return output as 0 or 1. So yeah, that's it. And let's see for our code for our client. So in our client, what we have is, okay, so this is our client. We import the libraries for n equals to 2. This is all our feature extractor on our client side. And this is the K1 most common n-grams from our training that we got. We saved it at here in a file. So this is all our credentials for AWS. We have invoked the endpoint and we upload exe files here, that is PE files. We can upload any number of files. And for those files, we can see that we load the featureizers. We do the same step that we did in the collab. And if output is 1, it's a malware. If it's else it's a benign software. So this we get, we append in our variable, and finally we print it out. So let's take this. But since this we we are uploading a PE or executable file, I think it is safe for us to do this in our virtual environment or a remote desktop. So I have Ubuntu and Windows machine with me in AWS, and I'm going to use those to see if it works. So let's go to our Windows machine first. So this will be our Windows machine. And okay, what you can see is in this machine, this is our streamlit.py file. Okay, let's see our, okay. So this is the directory. In here we have this our client and we have our featureizers. And these are all the exe file or PE file that we can use. So I will run this client here. So our client streamlit is being run, and this is local host. So you can drag and drag the file. So let's see for some of the files. Okay, I will use let's say one. This much file I will check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. More than 10 files I'm using. Okay, I don't know how many files are there, so let's check for 10 files. And let's see, classify. So there are virus and malware as well as benign files. We have uploaded it and we are trying to classify it. It's running and we got an array. Oh, sorry. So I wrote more than that. Let's 6 for 6 file classify. There was more files, more number I inputted here than the number of files. So sometimes, okay, let's wait. Still running. Let's see if there is an error. Okay, let's deploy it once. Let's run our client once more and let's check for just two for once. That sometimes it might give an error. Okay, so let's check for just this and this file. One is not a virus, another is a virus. And there are two files. Let's classify those. And there are classified reasons. So this is not a malware, the other one is a malware, right? Let's do this again for multiple files. So let's do from the here to let's say here. Open. I uploaded a very lot of files and let's check for 10 files if it works. Yeah, it's working. You can see as here. So these are all our feature vector that I printed on the terminal just to check if it's working. And you can see the classification here. So we got all the benign software. Let's check it once more. But now we'll just use from here, here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, maybe around 15, okay? 15. Classify. So why I have done this, because let's say we want to check for a directory. So we can select all the files in directory, but we can just select a number of files to be checked for quick demo. So this is for demo. So yeah, you can see, okay, you can see that this is a benign software, but it has been classified as a malware. But this virus are malware, so it has been classified as malware. So there are some false positive and false negatives as well. So yeah, this is for our Windows machine. I use Windows machine because it's easier and it's faster. Now let's check the same for our Linux machine. That's our Ubuntu machine. And this is also in our AWS. And so I think okay, you can see the lag. There is, okay. So I'm already run the client and let's just check by running it. So here it is. Let's browse the file. Okay. And let's check from here to here. So 1, 2, 3, 4, 5, 6 files. Okay. So let's check for 6 files. Let's check for 5. the classification, you can see virus has been classified as malware and the benign is benign. So yeah, it works perfect for here, this case as well. So this is for all that we have. Thank you for listening. If you have any question, please reach out to me. Good day. Bye.